Welcome to our YouTube channel, and our topic for today is complex numbers. And one idea behind complex numbers is the square root of a negative number. For instance, let's say we have square root of -1. Now if you have to find the root of this equation, that would be impossible, because if you say the square root of -1 is +1, or you say the square root of -1 is -1, that is impossible, because when you square +1, you will get 1, and when you square -1, you get a +1. Now the main idea around complex numbers is using I to represent this complex number. Now because we can't find the square root of this number, it is called a complex number, and the square root of -1 is represented as I. Now one thing we have to note is the square root of a negative number is I. Now of 1 is I. Let's say we have the square root of -3. How do we represent this using I? Now we can say this can be further expressed as square root of 3 times square root of -1, because when we multiply the both of them, we would get back this. Now remember that from what the mathematicians used to make it easier was they represented this as I. Square root of 3 times this as I, which is I. Therefore, this is square root of 3 then I. Now on to addition and subtraction of complex numbers. Let's say we have a complex number z1 to be 3 minus 5i, and we have another complex number z2 to be 4 plus 3i. Now we are going to be finding z1 minus z2 and z1 plus z2. Now if I have to find z1 minus z2, z1 minus z2 will be equals to 3 minus 5i minus the z2 we have 4 plus 3i. Note that this is just from our normal algebra. We just open this bracket by minus sign, which will be equals to 3 minus 5i minus times 4 is minus 4, minus times plus 3i is minus 3i. So from this place we will collect like terms, which will make it 3 minus 4 and then minus 5i minus 3i. 3 minus 4 will give us minus 1. Minus 5i minus 3i gives us minus 8i. By z1 plus z2, this will be equals to, we write out z1, 3 minus 5i, and then plus our z2, which is plus 4 plus 3i. This will be equals to 3 minus 5i plus 4 plus 3i, which is 3 plus 4 minus 5i plus 3i. We only brought the like terms together so we can sum them up and subtract them. This is equals to 7, then minus 5i plus 3i gives us minus 2i. Therefore, the sum of this complex number is 7 minus 2i. Now the imaginary part from this sum, z1 plus z2 is minus 2, and the real part of the sum, z1 plus z2 is equals to 7. Now that is basically all about the subtraction and the addition of complex numbers. So we'll be moving on to the division and multiplication of complex numbers. Now on to the multiplication and division of complex numbers. Let's say we have the first complex number 3 minus 5i and the second complex number 4 plus 2i. Now if I have to multiply this complex number, which is this z1 times z2, is equals to 3 minus 5i times 4 plus 2i. Now if I have to multiply these complex numbers, just like our normal expansion of brackets, this first value here multiplies every entry in this bracket, and this second value multiplies everything in this bracket, which is 3 times 4 gives us 12, 3 times plus 2i gives us plus 6i, minus 5i times 4 gives us minus 20i, and minus 5i times plus i2 will give us minus 10. But there's something I want you all to note, that I times I gives us I squared. Now this brings another conclusion we have to note. If we have the square root of minus 1 to be I, therefore if we square this both sides, the square cancel square, minus 1 is equals to I squared. Therefore this minus 1 can be represented as, this I squared can be represented as minus 1, which gives us 12 plus, let's subtract 20i from 6i, plus 6i minus 20i gives us minus 14i. Now from here we write minus 10, then our I square will be written as minus 1. This is equals to 12 minus 14i, then minus 10 times minus 1 gives us plus 10. Z1 times Z2 will be equals to, we'll sum the like terms together. 12 plus 10 gives us 22, and then we have minus 14i. Now to the division of these complex numbers. Remember from the multiplication, if we have square root of minus 1 to be I, and we square both sides, this square cancels the square root. Therefore, I square is equals to minus 1. How about we have I to the power of 5? I to the fifth is I times I times I times I times I. That is I to the power of 5. Now this would be equals to I square. If I to put it in the power of 2, this times this gives us I square, times this times gives us I square, and then we still have another I times I. Remember that from here we said I square is equals to minus 1. This is equals to minus 1 times minus 1, then times I. Minus 1 times minus 1 gives us plus 1. Plus 1 times I gives us I. Now we might have cases where we have to multiply I by itself 5 times, which is I to the 5th or I to the 8th, and the rest of them. But just to separate them just like we did for this, and then finalize and get our answer. Now if we are to divide this, we would rationalize. Rationalizing is the shortest way we could divide this number, this complex number. Now we can say we multiply up and down by this denominator, but there will be a change in the sign of the complex, of the imaginary part. That is 4 minus 2i divided by 4 minus 2i. We haven't changed anything in this equation here, because if we divide it by this, we'll still get 1. But because we don't want to have a complex number in the denominator, we have to rationalize so that we won't have that complex number. This is equals to normal multiplication of complex number like we did before. 3 minus 5i times 4 minus 2i. 3 times 4 gives us 12. 3 times minus 2i gives us minus 6i. Minus 5i times 4 gives us minus 20i. Minus 5i times minus 2i gives us plus 10i squared. Divided by, now we can just use the factor of brackets. We can, since we have 4 here and we have 4 here, and then plus 2i and minus 2i, we can as well just say 4 times 4 gives us 16, and then plus 2i times minus 2i gives us minus 2i squared. Now from our I square, we know I square is equals to minus 1. Now we'll be substituting I square for minus 1 and summing or subtracting the like terms together. This will be 12, then minus 6i minus 20i gives us minus 26i, and then plus 10, and I square is minus 1, divided by 16 minus 2, I square is minus 1. This is equals to 12 minus 26i minus 10 divided by 16 Then minus 2 times minus 1 gives us plus 2. This is equals to 12 minus 10 gives us 2 minus, we have our 26i divided by 16 plus 2, which is 18. Now, remember this, we can as well just find the imaginary and the real part of this by separating this like we will separate our normal fractions in our algebra. This will be equals to 2 over 18 minus 26i over 18. 2 here 1, 2 in 18, 9. 2 here 13, and 2 in 18, 9. Therefore, our final answer is 1 over 9 minus 13i over 9. Now, the real part is 1 over 9 and the imaginary part is 13 over 9. So that, stay tuned. Thank you for watching. Remember to like